right, welcome to AI FISEC today. This is a podcast where we're embarking on a thrilling journey into the intersection of artificial intelligence and the physical security industry. I'm super excited for our guest today, Pierre Bourgeix. He is the CEO and founder of ESI Convergent. And today he's going to be talking to us a bit about how AI improves safety, operational requirements, and business resilience. Pierre, welcome. How are you?
Great being with you on this show. I think we've known each other for a period of time. I'm glad this is a great liftoff in regards to the topic, as well as what you're doing in the industry. So fantastic.
Awesome. Yeah, and I'm super glad to have you, and it was great to connect while we were at GSX. So tell us, the audience, a little bit about yourself, your background, and we'd love to learn a little more about you before we go into the topic.
So yeah, over 30 years in the industry. Starting in the intelligence side, ran corporations, State Department Security Services, did work overseas, working to help our government do what it needed to do the right thing for the world and to create a peaceful world. So we were there for many years, and I was in that operative environment for about 10 years. Then went into a lot of the SATCOM, NAVCOM systems, worked with Lockheed and Donald Douglas. This is like in the 90s, right? So we're talking a long time ago. I saw the birth of using, technology that, frankly, today is very archaic, but the reality is that it has to start somewhere. Worked with the IT and cybersecurity world when it was in its infancy, obviously using technology that now is adaptive and become, in effect, the foundational elements of what we call AI, or I call it synthetic cognition, since I'm honestly trying to change that narrative a little bit from the IBM days. I think what it boils down to is that, I traversed that world of IT, OT, physical security. I saw the technology evolve, worked from the perimeter into the building, understood operational environments and the use of technology in those worlds. Obviously, by use of technology, also looking at security technology as well as operational technology, as well as IT technology, software as well as hardware. So, I've seen a lot of it, and with that comes a lot of experience and understanding. What do we do with this thing called AI, right? And the thing called synthetic cognition, as I'm going to coin it, and I've coined it over the last 3 years. But the reality is that from machine learning to deep learning to analytics and deep analytics, we've seen a transformation, right, in our entire industry, and I think that I've been part of that transformation, and I've seen a lot of things in that world. So. Today, my company, ESI Convergent, was created in 2017, after I worked with a company called Secure State, which we did a cybersecurity and IT security assessments, and then physical security assessments as well. Moved into working and developing a practice that really helps manufacturers from a technology perspective into the marketplace. We believe that there was a weakness in a lot of the ability for technology to really sing well in our industry, probably because, in many cases, we come from a very pedantic concept in terms of technology, where we saw the guys and guns, and, obviously response was critical, but technology was always in the back door, right? I mean, okay, great, we're using it, but frankly, we're just all about, can I get to the information quickly so I can respond and deal with the problem, right? So I think today technology really sings its own song, right? I mean, it's created an entire vision of a future that we never thought could happen in our industry. And I think really in the last 20 years, we've seen a true evolution, right, in the mentality of people understanding what technology means, and especially when it comes to convergence, right? IT and cybersecurity and physical security converging, right, from the use case side. And then, of course, data and how data is being used and how we can get to data and understand what that meant, right? So I think that we'll be able to talk a little bit about that today, And then, of course, our one of our larger practices, obviously, with our end users, we do a lot of technology roadmaps with large end users. We work with a lot of the big name companies, and we help them in terms of that roadmap. What is the right way to look at technology? How do we adapt to it? What do we have now? Legacy to future state. What does that mean? And how do we ensure that we're going to be successful over a period of the next 20 years? And are we positioned to be successful? And we look into depth on that, right? We evaluate their current state in regards to their technology. We ensure that they understand their acceptable level of risk and get them to really a desired state that makes sense, that limits their liability, that limits their risk, but it's at the same time positions them for success over time, right? So, it's not just about throwing, pieces and parts to the wind. It's about really analyzing the challenges of a business and its needs for technology. So,
Yeah, that's a great springboard into the topic. And as a side note, if you haven't met Pierre, you should. I mean, he is almost at every show, doing every presentation. And where I love connecting with Pierre on is that he's not just a physical security expert; he's also a cyber expert. And I think that basis is super important. Even more so, like nowadays, you hear news of the MGN and things that are happening in media, what's going to happen in the dark web with, I know that's not in the context of the AI discussion, but it's a whole nother ball of wax and maybe another podcast for a different day. But so yeah, if you don't know Pierre, you should definitely connect with him whenever you get a chance. So that brings us to the main topic, how AI improves safety, operational requirements, and business resilience. Kick us off.
wow, big topic, right? I mean, I think one of the biggest challenges in today's world of deep analytics, deep ML, I'd say deep ML, but when I talk about machine learning, what is the use of machine learning? What is the use of AI or synthetic cognition? And in many cases, right, we start back from where the data source is, right? So what comes down to this is you have to really identify how you're going to ingest, right, that type of data, and how are you going to, in effect, process that type of data to ensure that you're going to get some type of outcome, right? And what is an outcome? Well, the big question is, what does that mean, right? Everybody wants to say, well, package left behind. Well, that's analytics, red card, green card, analytics, right? But what does AI do? What does that word do, right? Well, it starts really at the end of the day with some crazy scientists who, built these incredible programs at Intel and NVIDIA, and they really created an engine, right? An engine for the development of processing that data, that metadata. And metadata meaning the data within data, right? That those granules of information that everybody misses when they're seeing something on television or seeing something on a screen, right? There's data within that data that's giving you the details and information that you need to start processing and establishing rules. Rules, that word everybody hates. Rules. The world of AI is all about rules. It's all about establishing, a premise and establishing how you get there. And I think that based on that is how do we solve the problem? What is the outcome? And today, it's not just about security, right? So we got to get to, that whole, you ask a question, but how do we get to that question? Why is that question even being asked? Well, it's because really what it boils down to it is that today technology can't be one dimensional. It's multidimensional. And with technology being multidimensional, you want products or things that you are gaining from that technology to help different parts of your business. Well, let's just put it this way. Security, there's certain things that you have to watch for, okay? I mean, we know those rules. But what happens when I say, look, can I use that camera for something else? It's at a loading dock. Is it possible that we could track pallets? Can we possibly track, how much time it takes to load a pallet? Can you tell me how many pieces are on a pallet? Now we're talking about some of the analytics stuff. But then we're talking about how do we take that data and start instructing it so that when it sees a problem, it tells me ahead of time. Oh my God, proactive data. So this is all about now how to take that and try to put it in a position where you establish the outcome. So if I'm a buyer of AI, right, I'm going to go to you, Mr. Manufacturer, and say, I want to solve this. Okay, but well, first, don't we want to like start from the basis? No, 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 no. I want to solve this. So I want you to tell me how I get there. So now it's about peeling the onion in reverse. We used to, the inside, we go the inside out. Today it's the outside in. Well, it's peeling the onion, right? But the reality is that we're no longer looking at the things that were intrinsically the problem. We're looking at how the problem can fix different things, right? It's not just one problem, it's many problems and multiples of those problems. And those outcomes are really critical. So what we're seeing in AI is that synthetic cognition AI has become, in effect, the roadmap, right, to solving business operational issues. And I think we began to see this when, Rockwell started putting cameras within those manufacturing lines. We started seeing that, when we saw, imperfections, and how do we determine a potential imperfection before it becomes an imperfection, right? So it's called continuous learning. Now, all of a sudden, we're getting into a different dynamic. So that continuous learning can't just be done by, say, some software at the edge. It needs computer vision. It needs power, right? You need to ensure that you have edge computing at that point so that it can define the critical versus non-critical, or the things before it gets to the cloud. Because I don't think anybody wants to basically store infinitum. You can't afford it. The terabytes, the petabytes of data, right? So at the end of the day, what ends up happening is we have to go into a data cloud, a data lake. And that data lake, which is basically a area, I'm trying to simplify it so that it makes simple for everyone else to understand, but think about a compartmentalized a cloud of data. And it's being able to silo that data appropriately and securely, and be able to retrieve it when necessary, but also be able to pull that data and then be able to investigate that data correctly by a data scientist or someone who is your AI in the cloud. Basically, that person, it's usually a person who's going to be able to review that data to start defining what the rules should be. Then it's logged back in, and now we have a rule, right? Now, that could take a week, that could take 2 weeks, that could take a month, depending on what the rules should be. This is now seeing the use of AI in the business world. Now, this is in video, right? We're talking video. We obviously see it in use in ChatGPT, start seeing in use in terms of data analytics, and use in terms of writing, informational transfer, all of that. So today it's multidimensional, right? So now we're not just looking at that, we're looking at access control, we're looking at identity management, all using the premise of AI. AI being the true AI, which means that it has to be in a data lake to actually be reviewed. You can't just say that you're AI. 9 times out of 10, I have to say it, this is a disturbing thought, but most AI today is really analytics, okay? It's deep learning, machine learning. It has much, I would say, greater than analytics, but it's not truly what we're thinking about as synthetic cognition, okay?
Yeah, one thing you mentioned earlier that amongst many things, there's a lot to unpack there, and I think that was well said. One of the things that's interesting to me is the idea of adopting AI as an org where you got to collect the data, but from a data scientist's perspective, like 80% of building models can be getting data, structuring data, labeling data, getting data from multiple sources, whether it's multi-cloud sources or on-prem sources. And that's a problem, because before the business says, well, I need to see the value, right? Let's say, that's not really the question. I think the question is, like you were saying, like we need to formulate the problem statement, right? Not, oh, it can increase my efficiencies. Well, we know that, like we can augment humans in many ways with AI today in so many different ways, but it's more of like formulate the problem statement. And then that's justification to say, well, you're going to pay a data scientist to comb the data to build a machine learning model within your work environment to get some use out of it. And now that's like been state for a long time, right? And like one of the things that I think is taking a lot of attention for me is around what Gen AI is doing. So a sub deep learning model and how those, where I'm curious about how those will allow for business to be more nimble or agile and maybe reducing the 80% workload to clean data and structured data, where now while they can still formulate the problem statement, they might be able to get to some sort of outcome faster. So I don't know what you've seen around in your space when it regards to operational requirements or business resilience and how Gen AI is maybe impacting that, or maybe it's not there yet. We're still
well, no, I think it's close. Now, there's two parts to that conversation, right? There's platform versus model, right? So the challenge right now is that many of the answers are around models, right? So we've created verticalization of problems. So that's the first thing. And that's the NVIDIA model, right? The NVIDIA model was silo problems. Now let's fix them and go deep, right? And start developing really the use case and the neural network around those specific verticals. Now, the challenge with all of that is that you can't do multidimensional processes, right? You process across a variety of different verticals and be able to now position the true, I'll call it triangulation of a problem, right? What is that triangulation? Because right now, if I'm really working in the vertical model, I'm only seeing specific problems in that specific area, okay? And that's the challenge with, what we talk about in terms of AI. There's a lot of misnomers, of course, by a lot of people who think they know what they're talking about, and I get challenged by the fact that what you're talking about two different animals, right? So if you have a model, you put a couple of analytics, or we'll just say a couple of scenarios, right, on a camera. Now you've got, 7, 8 scenarios, 10 scenarios, 15 scenarios within that one vertical model, right? And it could be based on, some true aspects of security and maybe some business analytics. But the challenge that I have at that point is, what about the rest of the story, right? And the rest of the story may cross over so many different types of problems. So I think that there's only a few companies now that are in that transition or building a platform-based, we'll say, AI programming, AI program, and that's where I think the magic could take place. I think at the end of the day, also, it's who's providing that data, right? So if you're, as you said, pulling data from a million different sources, right, or we'll just say maybe one source, and that data may be flawed in one way or the other, you now have to figure out the flaw, and therefore a reject, right? What we don't want is more false alarms. We want to stay away from the false alarms. We want to stay away from the false positives. We want to have as true data as possible to gain relevance to the problem. And if we keep on putting flawed data in it, we're going to get the same bad results, right? So it's either being instructed by seeing things and doing things its own self, and therefore learning based upon the actual event, or we're taking data from a massive field of information and ingesting it, and then maybe creating some very solid means, right? We're trying to create a mean, but the problem is that those specific flaws that you end up getting based on that impure data, that data that was false in the first place, could hurt you. I mean, heck, we've seen this. I mean, this is going on, and this has been going on. So a true data scientist within AI knows difficulty, right? They know this isn't going to be like overnight. But if you build a strong platform that is multi-use, multi-capable, that ingests data on multiple levels of sensor data, so it's just not video now, it's sensor data. So if we start triangulating that information and data stream and do it properly, we're going to get much closer to solid information, right? We're going to go, okay, that's 100% right. I mean, there's no way it's wrong because we've triangulated the data, we've got it right on target. And so, again, nobody says this is easy, by the way. And anybody who says it's easy is probably selling analytics.
Yeah, because there's a thought around edge compute and like spreading the compute. So it's almost like maybe that's where you're going with this, but like instead of pushing all the compute to one edge device, aka, or it could just be an NVR, right? NVR for like all terms. It's now spreading the compute across devices that are making a collective decision to say if these things are happening or these various scenarios are happening, then
and you got it. You nailed it. That's exactly correct. So when we talk about that, we're correlating data. So correlating data is really critical to successful AI, successful outcomes. If you can do, and I truly believe this, I've written a couple papers and I've added that aspect. People didn't understand it maybe 5 years ago when I started writing about this, 6 years ago. But correlated event tracking, right? What does that mean? When you correlate events and you tie them to good data, you've got true positive answers, right? It's going to come up with the right answer most of the time. Good data scientists want proof. They want reality. They want it to make sense too, right? So I mean, you can have a version of reality, but if you have the right reality that means it's true, then you're going to be okay. And that's it. Again, this is a world now that is here. There's no doubt it's here. The problem is you're going to find a lot of technology out there that's misusing it, right? So that is not really where it's at, where it needs to be at, or still in construct, or selling a dream, right? There's a lot of dreams out there. I call it hopium, by the way. It's a great drug. I try not to take it too much, but I sometimes have to drift into it.
I need I just need a book of all Pierre-isms.
Hopium, synthetic cognition. You got a couple of them.
I'm gonna wait. I'm just gonna be like, it's page 5. So yeah, that's interesting. You mentioned that. So this correlation. Because I mean, if you think about it, I mean, a human, they're correlating things to make a decision. Their senses, right? They're not just using their vision. They're using their hearing. They're using smell. They're using all sorts of things. And so you look in our terms of sensors. You're using glass breaks or vibration sensors, or obviously cameras,
or
right?
LiDAR, or anything.
Or vape detectors or whatever. And so, and if those things are true, and then I have a scenario, and then maybe one day they come out with this all-inclusive device that does everything. I mean, video is pretty powerful on its own sometimes, but I never really thought about that way. That like you bring AI to the mix, to the edge, that it's a collective, or like you say, a correlation of all these devices, data points that create this scenario, right?
And I think what it boils down to is that we are in a world of sensors, right? So everything is now tied to sensor data. As we develop a long-term, say, effect of this sensor data, there's going to have to be a plausible reaction to it, right? So if I'm running a manufacturing facility and I have multiple lines and I'm creating cheese, right? There's certain imperfections that are just absolutely not going to happen. And so I could translate that to saying, well, I have to correlate that data from the inception to today, and then have enough information where I can make a good decision that, wait a minute, this is flawed, and this piece of cheese is flawed. But the reality is that I know it's kind of crazy, but that's exactly it. And if you really look at business operational excellence and the future of our world today in terms of business, we are looking to reduce costs. We're looking to create lean processes. We're developing, obviously the optimum Six Sigma environment. The challenge is we can't get there because why? Human beings. Human beings are flawed. We'll never be perfect. But as we correlate data tied to the people, the process, the technologies, because one thing you can't eliminate is human beings. You can try, but human beings are still going to be there. The processes have to be there, because without the processes, we're kind of screwed, okay? So then the technology has to be able to master the possibility of people and process working in harmony to ensure the correlated events that you're fixated on for the outcomes happen the way you want them to. Can you imagine sitting in a world says, today I'm going to decide if this outcome is going to happen? And I could position that by in effect training a well-structured platform AI that will tell me exactly that I'm going to be right. Now, we're not there yet, but we're sure getting close because the speed of compute, the speed of infrastructure, I mean, obviously with chips and everything else that have now gone to the point where we're no, we're advancing so fast in terms of our way of machine learning and truly compute is at that level. Well, the next level is scary because once you get past that, it's quantum, right? And we're talking about quantum all over the world, but here it's kind of like, oh, a boat, but it's happening.
So let's talk about that, right? So it's going quantum down the road. Maybe this falls in some context of business resilience, but what I'll be curious to understand is like and obviously Pierre knows me, so I'm a huge fan of SaaS in the cloud, right? So this is not at all a selfish plug; it's a real question that. Yeah, NVIDIA will make these AI chipsets that are going to allow for scale and have all the transformers that are needed in order for a customer to build out their AI dreams. Okay, but that's also maybe that's not owned by the customer. Maybe it's a infrastructure as a service that they're farming out, right? And so I guess my question would be in our industry specifically, where they have AI surveillance systems that live on MBRs, and it's basically machine learning on the edge, pretty much, right? And so are the cameras. What point does hardware replacements become like an annual thing because of the intelligence of the systems scale more? Now, machine learning, I'm not too concerned about, but I think as we start to get into that next age of compute and that next age of AI, right? It makes me wonder, like.
So it's interesting. Yeah, it's interesting what you're saying, basically. So I'm involved in trying to create a retention guide, right, for the industry. We're working SIA, Video Vision team, advisory group, and the retention aspect is really critical to a lot of this conversation, but it's more of a legal discussion. The other one that you're saying basically is very interesting because as we move towards quantum, and we'll just say future technology, right? Because we don't know what's going to happen next. We do, but we don't, right? So if you think about it, right, what is the one thing that we don't have to worry about, right? We don't have to worry about one thing. We're going to get ingestion. I think camera's a camera right now. You're going to get pretty good, information out of a camera. The key to this is transmission, right? It's really communication. The world that we're living in right now, right? So I have four legs to the stool, right? Secure communication, secure identity and privacy, secure cloud and storage, and then secure entry into everything. Those are the four domains, period. End of story. I don't care what you tell me, I know I'm right, because that is absolutely the four domains. Now, and especially in the world we're moving into, right? Those are the four domains, no matter what. And you may be a SaaS, PaaS, IaaS, I don't care where you fit in this puzzle, right? Organizations will do what they do, hybrid models, non-hybrid, one-dimensional cloud solution, SaaS, no matter, okay? The key is communication because we can't transmit that data. We can't do anything with it. If we can't create stable communication, we've got nothing. So what I think what's going to happen is as we progress, the key to this will be to ensure that we have distributed communication, distributed infrastructure for communication that's much more solid than it is today. Today, honestly, it's almost solid state. we in many ways, we've created a lot of great things, but we're still stuck. I mean, look, we're trying to figure out 5G, which is in 5G, it's 4.3G. The reality is that it's not really stable, right? And I don't believe anybody can say to me, oh, got a stable communication path. I'm like, really? Show me. And I can tell you every time I hear this, It's up and down. And more data, more what? Problems, right? So until we get there, right, all this can't be solved, right? Because we can create a lot of edge technology, but if we can't create solid communication strategy and solutions, that's why do you think, okay, when we talk about smart cities, what's been the challenge? Communication. It's truly communication. That's been one of the biggest challenges about deploying citywide surveillance. It's how do we get that communication solid enough where we're going to get that data? And it's usually, okay, can we go wireless? Okay, can we do a ring? Can we do that? Can we do this? Can we do that? And a lot of times it's a combination of everything. Okay, but the reality is that it's still complicated. So yes, I think that we solved that problem, and we solved the uptime and the ability to get to cloud and to be able to manage data very fast at low cost. Game over.
Yeah, and really, like, I'm sure these systems, because we're not making like manufacturing systems, right? I mean, this isn't. I don't want to say it's not mission critical, because that's completely wrong. I'm saying it's just not like one that I think has to innovate every year, right? Like they can kind of foresee what challenges, and but what will make it interesting is how customers start and specifiers start to scope and integrators start to scope projects considering this, right?
Because they right now.
Yeah, you can't just think, oh, let me give you 20% NVR storage capacity and for your analytics and blah blah. Like, no, it's like, wait a minute. How's this compute going to spread across? How's it going to transmit? Do we have enough bandwidth, not just for your video feed, but for spreading the algorithm love right across the system? So, man, that's going to be fun times.
Yeah.
I'll get Pierre to write up my scope of works though, and my bombs.
Trust me, I've been working on this for a little while, and it's not easy. I mean, we've picked at this problem, but it's still out there, and we'll see. I mean, there's a lot of good answers for this. Don't get me wrong. I mean, there's a lot of great answers. It's just trying to unify it, and I think that we tie this to companies that deal with unified communications, tied with network stability and security and safety along that environment. Again, security is a big key to this, right? You want secure communication. You don't want just communication. I could give you open-end communication all day long, right? But the problem is that it's not secure. So I think that's the challenge, right? I mean, I've got good buddies that work on SCIFs and work on secure communication protocol for environments. Man-made networks. It's either you go like that or you're out in the ether. So it's a challenge, and I think, but that's leading us to business operational excellence, right? We get that figured out. The Rockwells, the Siemens, the big boys who are producing OT infrastructure and controls.
Right.
They are going to love that next step.
Right. So Pierre, we got sub 3 minutes left, maybe 2.5 minutes left. Tell the audience maybe something you're working on, something you're excited about, also where they can find you. Take us on.
So I'll take about 50 seconds to talk about what we're working on, which I love. Lance Holloway has joined our team, and since he's joined our team, he was out of Stanley Security Technologies. He was the one who was in charge of that world. He's now our CTO. Boy, I'll tell you, he's been a godsend. He's produced, with my help, and we're working together on a lab services program, right? A lab that really recreates networks and recreates scenarios, right? Builds at a physical location. We are partnered with a couple companies out on the West Coast, and that are helping in terms of lab services and testing and all that. Our goal is to really become that next step to the testing environment and lab testing environment for the security industry. In many cases, we are trying to develop the scenario so end users can see how their technology is going to operate in their environment, while still being an environment that's not their own, right? As long as we have the schematics and the network infrastructure and figure out specifically how they operate, we would be able to replicate that environment and then test solutions that they're looking at. A lot of companies, frankly, have been doing this themselves, but they realize well, they're banned or they're not they shouldn't be doing a lot of this stuff. So long and the short of it, that's what I'm excited about. I'm excited about working on some standards with SIA. We're working on, obviously retention times. I'm trying to, build out an equation. I have an equation. We're trying to format that under legal circumstances. Privacy is a big one we're working on. I'll be at the BIPA because I'm speaking at this at ESUM's facility up in Chicago on BIPA. That's going to be this week. And then how to get me, Pierre at esiconvergent.com. You can get me directly. I do pay attention. esiconvergent.com, our website. You'll get someone. We've got lots of smart people who can solve a lot of difficult problems.